Very good morning to all of you. Today we are starting with the census and transmission. That is a new subject to for semester, and that is census and transmission EI Kozova. Okay. Now it is a very much a versatile subject and that is very important for your code to know what is basically census. Whenever you are designing or developing any kind of designing or developing any kind of your uh, system, then it's very much vital for you to understand how to sense any physical variable. So, just quite different from the amplifier or whatever you have understood in the previous classes through the different subjects. So, sensors and transducers are also those kind of devices, but it is fully different from its sensing property, and that is it is sensing basically the physical signals. Okay, so physical signals like temperature, pressure, humidity, etc. that will be sent through the sensors, and that will be coming into the measurable form of output, measurable output, and that is through the transducer. So that's why sensors and transducer parallelly that we have to understand and we have to study to develop any kind of measuring systems, okay, or any kind of control system that we will generally do. Okay, now let's move on. So, what is basically sensor? You have to understand. So that's why, first of all, we will go through the syllabus. Let's move on. So, what is the subject mean? Subject means your sensors and the transducer. Okay. Subject means your sensor and transducer. Now, give me 1 minute. So, your subject means your sensors and the transducers, and your subject code EI401. Okay, this EI401. Now, so it is EI401. Now, what you have to understand here, let's move for the different modules. It is included in your syllabus. Okay, it is included in your syllabus. That is basically okay. So, what we have here is basically your objectives, course objectives, and that has already explained over there, as well as the course outcome also. We have the four outcomes. So please go through all those outcomes. That's very much important to understand your syllabus. And then the reference book I prefer basically the D. Potronovich, okay, Census and Transducer, and it is as well as we have another Karamazov publication to the Berlin for the measurement purpose, I prefer. Okay, as well as we have the different kinds of applications of the census and transducer we will get in a specified book that is very much interesting book that is the biggest one. Okay, so my preferable book if you want to know for your reference, but nothing but that you have, okay, and that is your and just after marking all these books and please note it down. It's very much important. Number one, that is your reference book, that is every opportunity sensors and transducer. Then you have for the measurement purpose grading and we have previous one. Okay, these three books are very much important. Now let's move on. So what we have here. So next part is I'm just clearing all my sketch. So So let's find here what is basically a sensor. Okay. Now, if I prefer to write over here, so sensor is mainly developed to sense basically a physical signal. Physical signal. Okay. Now, what is basically physical signal? So, what if I say that the physical signal mainly we can say there is the temperature, pressure, humidity, as well as you have suppose a level, water level in the tank you are sensing, and then you have force you are sensing the mechanical signal. Obviously, if it is force, then there will be the displacement. Then you have to understand if it is displacement, there will be the acceleration or velocity. If it is acceleration, all other physical quantity you are converting into the, these are all the signals, physical signals. So physical signals, and as well as you can say the radiations, that may be nuclear radiations, like that may be radiations. So you can sense the radiation also, that may be light radiation. So these are all kinds of physical. Okay, so we are sensing through the sensor. So now what is basically sensor? So sensor is providing actually the detection of very much important. The detection of those physical signals. So sensor is a device that will basically produce that will change you can say the certain amount of input energy into another kind of a same form in the output energy. Okay, so certain kind of input energy that will be converted into another kind or the same kind of energy at output. Okay, so it is basically detecting the presence or absence. That means basically detecting the presence or absence of the physical signal. So it is detecting presence or absence of the physical signal. Now, in case of transducer, it's quite different. Is that while transducer having its initial block or the initial phase, that is basically the sensor. Okay, so if I say the transducer is nothing but whenever we are sensing certain amount of physical signals, so the output cannot be measurable or output cannot be observable one. So in that case, output cannot be measurable one, measurable quantity. We cannot record that amount is very smaller quantity. So in that case, in case of transducer, what will get, this transducer will convert basically the, after sensing the transducer will convert the physical signal into measurable output, into measurable output. Okay, that output generally preferred electrical. That output is generally preferred electrical output. Why it is generally preferred electrical output? As because you know we can easily process the electrical output. So we can easily process furthermore the electrical output. So the transducer is nothing but having it the sensors as a primary sensing element, and then that measurable that output of the sensors is cannot be measurable, is sometimes it's not measurable. So in that case, that measurable output we require to record or to further process, right? So that's why here we require basically the transducer that will convert the physical signal into a measurable output. And that measurable output quantity, that will be electrical output. It may be non-electrical output also, but electrical is preferred. So that's why we can easily process that electrical output for the further processing of the signal, right? So that's why the big difference in between the sensors and transducer is that both basically sensor is the primary sensing element of the transducer. So whenever we will draw the block diagram of the transducer, so what will get that the primary stage of the transducer we will get the sensor. And then there is a converter followed by a converter. That means whatever be the output is coming and that crystal signal will be converted into measurable output and that therefore the measurable output that will be the electrical current. Okay, that will be the electrical current. Now, why it is so much versatile? Why it is included in your syllabus? What is the use of sensors and transducer in your syllabus? That is very much important issue. Okay, let's suppose take an example. I'm clearing on my sketch. Let's suppose take an example. Okay. So whenever suppose in case of suppose we are sensing the we are basically having it say sensor is not it's not now clear to you right because you know suppose we are taking the example of the yeah, okay or sorry AC machine. So AC machine. Okay. So in that case we have temperature display you have seen the temperature display and suppose your room is that you want to maintain the temperature of your room that is suppose 25 degrees centigrade. Now instantaneous temperature, instantaneous temperature, instantaneous temperature that may be 27 degrees or that may be lesser than 25 that means 21 degrees suppose. So in that case how it will be obtained that the instantaneous temperature is now different than whatever we uh, have the desired outcome. Let's take a look okay, to understand this one. Suppose whatever we have set that is basically turning as the desired output that is your 25 degree centigrade. That is called a set point. Okay. Then set point you have set for your system and that set point that will be always compared and direct signal will be generated. That is suppose P2 reversible. Then your process is your there's certain terms and terming that is say controller or becoming like a controller. Then or the manipulator. Okay. Then you have here the process. So your process is you want basically the process should be maintained at 25 degrees centigrade. So your plant or process that is your term is plant or process. Now you will maintain the process temperature and the output is coming. Suppose it is CT. It is called control variable. Okay. So control variable that is nothing but your temperature you are getting. Okay. Now how this temperature information that will be that will fed to this comparator here we will get that our now instantaneous temperature of this room is not exactly 25 degrees centigrade and how the controlling function will be done over that error, how the error signal will be generated. So there is a scope of sensing that temperature. Okay, there should be a scope of sensing the temperature over here. So we are putting here a temperature sensor. Right? We are putting here the temperature sensor which is directly attached to the process. So our temperature sensor is our temperature sensor. Temperature sensor sensing what is the instantaneous temperature is now. That is suppose now it is 27 degrees centigrade. So that information will be fed to the for the comparison purpose, and that will be compared with that segment, right? And that a signal will be generated. What is error now? That will be obviously our temperature should have to be decayed, right? That's why the error will be here 25 minus 27, that's minus 2. Minus 2 is indicating basically controller input is indicating basically whatever be the manipulation that will be done to the controller, the respective output will come to the plant such that that temperature may be decreased. Okay, that controlling function that will basically handle it, and minus 2 degrees centigrade comfortable output that will be provided to the plant such that the plant operation will be like that. Here it is a compressor, so the temperature may be decreased, right? The temperature may be decreased. So in this way, our basic element is very much that is very much needed for each and every process. Wherever you have to sense what is the instantaneous output, what is the instantaneous output, and how could you control that output is very much important issue for any kind of closed loop system or any kind of system. Okay, or you are indicating locally. Suppose you are indicating locally the temperature indicator. So you are indicating locally over there. The temperature indication is there. Okay, so you are getting that. Now it is 27 degrees centigrade, and that will be taken down because our process need to control them at 25 degrees centigrade. Okay, so that should be done through the temperature sensor. This is very much vital or unique as well as the important issue for each and every process. So that's why it is very much versatile. That's why sensor transducer, your syllabus is constructed like that way. Every sector of the sensing physical signal that we can cover. Okay. As a whole, we will get the knowledge. Okay. So this is all about the application, main use, and why should we go through the syllabus of the sensors and transducer. Why should we need the sensors and transducer for the practical application as well as bring up the process? Now, what is the basic block diagram I can represent over here? Let me take my pen. The block diagram we can represent over here. That is, I am sketching over there. That is your, suppose it will be your primary sensor. This primary sensor, okay, that will provide the signal, and then we will have another block to be needed to get basically a converter. So this one is primary sensor and this one is signal converter. Okay, that will give you certain measurable converter compatible output. Okay, so we are having with the physical input, physical signal. That physical signal will be sent to the primary sensing element. So PS is referring over here primary sensor. Okay, and LC is mainly it will be termed as transducer, that is it will be termed as a signal converter, you can see signal converter. Okay, so what we get here, the physical signal that will be sensed and we are getting certain amount of suppose mechanical output. Suppose mechanical signal we are getting has a mechanical output we are getting. So that mechanical output that will be converted into electrical one is certain mechanism that is called the transduction mechanism. Transduction mechanism, and we will get the electrical quantity as output, suppose electrical output, and or any kind of other form of it may be pressure signal, okay, like that, but it will be comparable for the measurement as well as record, as well as it may be processed further. Processed further. Okay. So this is mainly the block diagram of a transducer, you can say. So it is the block diagram of transducer. Okay, very good. So this is all about sensors and transducer basic concept. So I think this enough to build up your concept regarding the sensors and transducer. Now what is the classifications we can put here? There are the different kinds of classification. So we can put here the different kinds of classifications. So number one, we can put here classification on the basis of transaction principle. Okay. Number one, on the basis of transaction principle. Transaction principle. Number two, that means it will be resistive capacity, inductive, magnetic. Okay, like that. So that will contain transaction principle means whatever be the property, resistive property of the basic transducer, that will be changed. Resistance will change with respect to that transaction principle means the resistive property. That means resistance value will change with respect to certain amount of physical energy. Like the capacity property of the transducer will change with respect to certain amount of physical energy. Okay, so we will observe basically del C in that case, we will observe basically del R in that case, we will observe basically del, suppose L in the case of del M in the case, it is mutual inductor. So like that, it will contribute. Number two is that there are basically primary sensing element, sorry, primary sensor or secondary sensor. So primary sensor means basically what? It will sense as the single stage sensor. You can say this is the single stage sensor. Okay. And secondary sensor means what? There will be two stage sensor. So we will go through one kind of uh, what do we say LVDT, that will be the example of particular secondary sensors, or you can say LVDT along with the bottom tube. That is primary sensing unit will be a bottom tube, and then LVDT that will be working as a secondary sensors that will sense basically the pressure as a physical unit. Pressure as a physical unit. Okay. So pressure through the bottom tube that will be converted into the displacement pressure through the bottom tube that will be converted into displacement, and then through the LVDT that will convert it into voltage. So it is the example of secondary sensor. While in case of primary sensor, we can put here the example as piezoelectric sensor, piezoelectric transducer, you can see transducer. So while there is a mechanical force of vibration, mechanical force or vibration that will be converted into directly electrical voltage. So that is the example of primary sensor. Then we have another kind of division we can put with the classification we can put, that is digital with respect to its output, that is digital or analog. Okay, so we will go through that example of digital sensor, that is moving the input. Input. In case of analog, we will get a potentiometer, then we have the capacitor, capacitive type or inductive type, different kinds of all other sensor mainly handling basically in the domain that is analog. Okay, then we have another kind of classification is possible, that is active and passive. Is very much important. Okay, that is, let me clearly sketch. Number four, that is active or passive. So active means what? Active or passive transmission. So mainly these are the classifications. Passive transmission means what? So it requires basically the power supply. So here we can put here potentiometer or strain gauge. These are the examples. Whereas in case of active transducer, we will get, or we mainly generally give that example, that is piezoelectric transducer. Piezoelectric transducer. These are all the examples you can set, and this is basically all about the classification of the transducer. So today we have studied what is basically the sensors and transducer, what is the basic difference between sensors and transducer. Okay, what is the classification? So these are all important questions. You can say these are all important questions also. So question will come that is very much important. There's a basic difference in between sensors and transducer. What is the basic difference? What do you mean by, what do you mean by transduction principle? Draw the basic block diagram of transducer. What is active and passive transducer? Give example of each. Another important question is this: what is primary and secondary transducer? Give example. These are a sort of important questions that will come from this part. So thank you for today, and I will not elaborate much more. So thank you. Thank you. Have a nice session.